Are the heavenly bodies of the sun-based framework influenced by a visit from an unfamiliar star? The most recent discoveries propose that billions of years ago, a heavenly visitor flew so near our home system that it steered thousands of tons of little divine bodies. Some of them may have been pulled out of their trans-Neptunian orbits and heaved into the inner solar system, where they were eventually caught by the huge gas giants as moons. But that is not all. Another exciting hypothesis is now advancing the possibility that our home system was shaped in part by a close encounter with another star. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yes. And then what? When we consider our solar system, we often assume that it ends at the furthest known planet, Neptune. However, this thought does not correspond to galactic reality, since, as a matter of fact, a long way beyond the orbit of Neptune, there are two equally remote and vast regions, the Kuiper Belt and the Oort cloud, which are believed to be the origin of comets. Suzanne Fair from the Jülich Research Center notes that this is in no way a scanty assortment of cosmic flotsam and jetsam. On the contrary, several thousand of these trans-Neptunian objects have now been found. However, sometimes this data is also connected to a higher-level mystery. Thus it happens that the unpredictable orbits of these objects, which are inclined relative to the planetary plane, have long been a complex problem. Luckily, we now have the technology to solve the inexplicable problems of our time. More specifically, Fair and her associates from the University of Leiden in the Netherlands conducted over 3,000 virtual simulations to uncover the cause of the surprising orbits and to see if the bizarre orbital characteristics of the trans-Neptunian objects could be traced back to the influence of another star. They were successful. The main conclusion for the astrophysicists was that a single close flyby by a heavenly guest is indeed capable of explaining the unusually inclined and erratic orbits of the trans-Neptunian celestial bodies. This even applies to those objects that are relatively far away, such as the dwarf planet Sedna, found in 2003, which on its journey through space comes surprisingly close to the Sun. Just to recap, 1 astronomical unit is the average distance between the Sun and the Earth, or around 150 million kilometers. The origin of those objects that move in orbits nearly opposite to the planetary orbits can also potentially be explained with the help of a close stellar flyby. However, the same applies to the celestial bodies 2008 KV42 and 2011 KT19, which made cosmic headlines after their discovery because they move in the opposite direction compared to the planets closer to the Sun than Voyager. But how exactly did the star flyby happen billions of years ago? And what did the corresponding heavenly body look like? Well, in this regard, Fair states that the nature of the modern outer solar system can best be explained by the flyby of a star with a mass of about 0.8 solar masses. Moreover, the simulation showed that the star passed at an angle of around 70 degrees to the planetary plane and a distance from the Sun of about 16.5 billion kilometers. In other words, the brilliant outsider was closer to the Sun than the 2 Voyager probes are now. In fact, Voyager 1 and 2 have now traveled to 2,465 and 2,061 billion kilometers away from our host star, and as is well known, they are currently exploring the mysterious world of interstellar space. This fact is even more astounding when we consider that the twin probes, which are identical in design, only set out into space in 1977 to study the outer parts of our solar system. While they were doing this, they were also supposed to add several new moons to the star charts in the domains of the gas planets. We now know that Jupiter, Saturn, and company are sometimes joined by moons that could be very strange indeed. Scientists expect that our Earth's moon and many other moons were formed along with their planets, and thus they also orbit their planetary fixed points prograde, which amounts to nothing other than that they follow the rotation of their planet. However, this does not apply to all natural satellites. Jupiter and Saturn are joined by a strikingly large number of moons that act unpredictably and orbit their planets retrograde, or in other words, in reverse, if you like. And while this normally also happens in highly inclined elliptical orbits, the rotational pattern is firmly in retrograde hands. In the case of Jupiter, astronomers count a total of 71 satellites that move in the opposite direction to the planet's rotation and only 16 prograde moons. For Saturn, The retrograde to prograde distribution is even 100 to 22, and for Uranus and Neptune, the proportion of irregular satellites altogether exceeds that of normal ones. But how can this be explained? How is it that we find so many moons here that differ so greatly from the normal pattern? Well, quite simply, the scientists suspect that the retrograde moons did not come into existence along with their planets, but were captured by them later. It is entirely possible that the original home of these peculiar companions is in the Kuiper Belt. On the other hand, however, this also implies that something likely caused the celestial bodies to lose their status as trans-Neptunian objects and become moons. What caused the appearance of the moons? Well, some time ago, the answer to this question would likely have been the migration of Jupiter and the other outer planets. In this case, Jupiter specifically may have once moved through the early solar system like a planetary wrecking ball, completely shaking up the current structure. However, Suzanne Fair also points to the stellar flyby theory regarding the retrograde moons. On one hand, it's in the nature of things that a celestial body with 0.8 solar masses would have triggered tremendous gravitational upheaval, and on the other hand, this assumption also aligns with the results of the programmatic simulations. In principle, the cosmic disturbance could have shot most objects in the outer regions of the solar system even further outward, or even all the way out of our home system. But the model also showed that 7.2% of the trans-Neptunian objects were shot inwards. In total, we are talking here about up to 10 million objects of 100 kilometers in size, or up to 10,000 objects larger than 1,000 kilometers. The main point is that some of these objects were gravitationally captured by the powerful gas planets and became moons. This theory also agrees with the retrograde to prograde distribution referenced above in the Jupiter region. The trans-Neptunian objects were 3 times more likely to end up in a retrograde orbit than in a prograde orbit. At Saturn, it was nearly 20%, and although most of the new satellites were subsequently shot out from their orbits, a sufficient number of captured moons remain to explain the presence of the irregular satellites today. The way a star looted the young solar system is indeed quite straightforward. As we can see, the central issues about the planetary system do not necessarily require multiple convoluted answers. According to the scientists, the real intrigue of the stellar flyby model lies precisely in its simplicity. After all, it's able to resolve an entire series of cosmic mysteries with just a single cause. However, this heavenly visit is by no means the only one that Suzanne Fair has previously studied. She and her team found that the young solar system once narrowly escaped disaster and was fundamentally altered in the process more than 4 billion years ago. A star with a mass somewhere between 0.5 and 1 solar mass is believed to have passed through the outer edge of the solar nebula. This brilliant celestial body is thought to have approached our young solar system to within 100 astronomical units, multiple times the distance between Neptune and the Sun. As the star passed the edge of the solar nebula, it tore some of the material with it. Ultimately, it is possible to explain many oddities of the present outer planetary system against the backdrop of this celestial assault. Although, as mentioned, numerous celestial bodies have already been identified there, galactic models actually suggest that a lot more objects should be lurking beyond Neptune. In this way, Fellner and his associates even believe that the mass of the Kuiper Belt region was reduced to around 1% of its original mass because of the flyby. Furthermore, the stellar passage not only explains the unpredictable orbits and the inclination of many trans-Neptunian objects relative to the planetary plane, but also the mass ratio of Neptune and Uranus, as well as the presence of 2 separate populations of celestial bodies in the Kuiper Belt. According to the scientists' model estimates, the likelihood of such a close stellar flyby is 20% to 30%. Evidently, only one heavenly body is sufficient to explain the characteristics of the planetary system, from unusual orbits to retrograde and prograde moons. While we have discussed the terms prograde and retrograde extensively today, digrade has sadly been somewhat overlooked. However, if you've enjoyed our video, please tap on the like and subscribe button now. Join our community to stay updated in the future. See you soon.